This is chapter 6-5, Trapezoids and Kites, video number 3. The last installment of this particular section deals with the mid-segment. And here in this particular segment, we were talking about trapezoids. And let's suppose we have a trapezoid. In this particular case, we have trapezoid A, B, C, D. And in this trapezoid, let's say we wanted to find the mid-segment. Okay, first of all, let's recall that on trapezoids, we have at least one pair of opposite parallel lines. So BC is parallel to AD, and I know that because of these arrowhead symbols. And again, the mid-segment, if you didn't already write it already, of a trapezoid will connect the midpoints of the leg. So the green line is our mid-segment, which means if I give this endpoint a name or number here, let's say I call this Y. That's an ugly looking Y there, but there's a Y right here at this particular point. And then on the right end, this is Z. Well, YZ is the mid-segment. It's exactly in the middle of BC and AD. And we can calculate the mid-segment simply by doing just a little bit of algebraic work and calculations. All right, here's the midpoint theorem. The midpoint theorem for trapezoid states that the midpoint of a trapezoid is parallel to each base and its length is the average of the lengths of the bases. What does that mean? Pretty simply. Okay, if I have trapezoid A, B, C, D, and I see that MN is the mid-segment. First of all, I see that BC is parallel to AD. I see that because of the arrowheads there. And if I notice that BC is 7 and AD is the length of 13, I can find the length here of the mid-segment by a simple equation. All you need to do is just take the average of BC and AD. If you recall what average means, it just means that the length of BC plus the length of AD divided in half. Here's the written equation here. MN is parallel. First of all, we need to know this is part of the mid-segment. MN, which is the mid-segment, is going to be parallel to AD, and that mid-segment MN, because it's a mid-segment, MN is also parallel to BC. And to calculate the length of the mid-segment MN, the equation says MN, the mid-segment, will be equal to 1/2 of AD plus BC. A bunch of words in writing to simply say what? Okay, let me move this here. I wrote it earlier, so let me move it here. I want to move it up here. Okay, simply, I need the average of BC and AD. So the length of BC is 7 plus the length of AD is 13. Together they make 20. And all you do is divide the 20 in half, which is 10. That's the length of the mid-segment MN is 10. That's it. So here, I've just found that the length of the mid-segment is going to be 10. Okay, again, to find mid-segment is just the average. So BC plus AD divided in half, and BC is 7 plus AD is 13. 7 plus 13 is 20. Divided in half is 10. That's the length of your mid-segment, 10. Plain and simple. That's all you need to do. Okay, next bit of information. Let's suppose we have a trapezoid, and it's on a coordinate plane like here. And I'm given the values or the point values here. Where I can see, in other words, B is at 0, 5, C is at 4, 7, D is at 7, 4, and 5, and A is at 5, 0. Okay, well the question is this a trapezoid? So let's say, I don't have this information here, I'm erasing it out. Let's say that I'm given some polygon, BCDA, and I want to know if this is a trapezoid. Well, what's the definition of a trapezoid? Trapezoid says that at least one pair of parallel lines. I hate to say the word looks like, because you know I've talked about the word look like. It looks like BC is not parallel to AD, so I wouldn't try that first. I will look to see if CD is parallel to BA. Okay, how can I do that? First of all, going back old school, I can use the slope equation. And if the slope of CD is equal to the slope of BA, then I know that CD is parallel to BA. Okay? Again, I'm trying to find out if the slope of CD is the same slope as BA. If the two slopes are the same length, or congruent I should say, then that automatically means that CD will be parallel to BA. And I'm going to move this up just so you can copy it for a second. Hopefully you've drawn in a coordinate grid and line. I'm going to move this down so you can draw the coordinate line. And what I want to do first, again as I stated, is that I want to find out if CD is parallel to BA, if they are parallel to one another, or in other words, if their slopes are congruent. If their slopes are congruent, that automatically means they're parallel. If their slopes are congruent, then that means that this polygon BCDA is going to be some type of trapezoid. So here we go. Now that you've had a few seconds to copy that, because, and this time I wrote it as ABCD, but it doesn't matter which way. I can call it BCDA, it doesn't matter. Because ABCD is supposed to be a trapezoid, I'm looking to see if AB and CD are the bases. And you have to remember, the bases are supposed to be parallel on a trapezoid. That means that the slopes will have to be the same. And to find the slopes of the line of segments, remember the slope, and I'm going to write this off to the side. I'm going to cover this up. Okay, slope equation. Hopefully you remember from Algebra 1 that the slope says M is equal to delta Y over delta X. And if you remember what delta means the change. So that's equal to, in other words, Y2 minus Y1. And it doesn't matter which one you call Y1 or Y2. Divided by X2 minus X1. Alright, and this is the slope equation you learned back in Algebra 1. And let me erase this just a little bit because that's cutting into the frame there. Alright, so here we are. Ta-da. Alright, so using this equation to find the slope of AB is delta Y over delta X, so Y2 minus Y1. Okay. And hopefully remember 5 minus 0, so if I come up to the top and scroll. Alright. That means I let the B's be the 2's and the A's be the 1. So what's my Y2? Y2 was 5 minus 0. That's why I have 5 minus 0 over the X's. What's my X's? Again, because I let this 0 be the 2's, that means 0 minus the 5, which is what I have down here at the bottom. And if you have trouble with remembering slope, you need to come see me. 5 minus 0 is 5 over 0 minus 5 is a negative 5. 5 divided by negative 5 is a negative 1. So the slope of AB is negative 1. In order for CD to be parallel, that means that CD must also have the same exact slope of negative 1. And we're getting ready to check. So the slope, I have 4 minus 7 over 7 minus 4. So let's look and see. At the top, I have 4 minus, and I'm going to use a different color here. I'll use purple. All right. 4 minus 7. So that means that I let the D be the 2's and the C be the 1. So here's my 4 minus 7 right here. There it is. Y2 minus Y1. 4 minus 7 is equal to a negative 3 over the X2, which is 7 minus 4, which is a positive 3. Negative 3 divided by positive 3 is a negative 1. And because both these slopes are the same, that does mean that AB is parallel to CD. AB is parallel to CD because the slopes are the same. Okay, and here it is written. Since the slope of AB is equal to CD, then they are parallel. That means automatically that the shape or the polygon ABCD is a trapezoid. So now that I know that this is parallel, what I can come in here and do is I can put this little line, boom, boom, the arrowhead in there to show that they're parallel to one another, because we just discovered that the slope of AB is parallel to CD. And then, are the slopes BC and AD supposed to be the same on a trapezoid? The answer is no. The answer is no. Okay? Now, let's say I want to find the mid-segment to find out where I should draw this line here. And I'll use a different color here. Let's suppose I wanted to know where I could draw, where's the mid-segment. Okay, I don't know where exactly, I'm just guesstimating. I don't know where the mid-segment is. It could be here, it could be here, it could be there. I don't know exactly, but I could calculate that. And if I wanted to find out where exactly I'm supposed to place this first end here, if I wanted to know where to place this first end, if I'm supposed to place it down here, if I'm supposed to place it up there, if I'm supposed to place it here, if I wanted to know exactly where to place that point, I can go back to chapter 1-5 and use the midpoint equation to calculate that. And if you've forgotten how to do that, go back to your chapter 1-5 and look up the midpoint equation. I'm not going to get into that at this particular point. That'd be left for you. But if you wanted to find out what the midpoint was, I could do that. And to find the midpoint, it'd be x1 plus x2 divided in half, and then y1 plus y2 in half. And to find that, I would use, so to find out where I place this particular point here, I would use B and C. I would use point B and point C because I would need the midpoint of those 2 points. Okay, and there's chapter 6-5.